Hey there, how you guys doing? Okay, so let's look at these directions. Write each trigonometric expression as an algebraic expression in U. Like, what the heck does that mean? Well, let's take our pieces to our puzzle. Order of operations says to take care of what first? Parentheses. So the first thing I'm going to look at and take care of are my parentheses. So the first thing is I'm going to look at the tan inverse of U. Now, when I see the inverse, I know U is not the angle. I know that I'm looking for the angle. Are you with me? And me personally, I don't like the inverse function as well as I like the regular function. So I am going to take tangent of both sides, which tells me U equals the tangent of theta. With me? Okay. And the tangent of theta is y over x, right? It's also opposite over adjacent, right? So isn't that just u over 1? So tangent is actually a fractional answer. And as I'm talking about this, and as you and I are dialoguing, I'm like, wait, tangent is from a right triangle, and we just said it's opposite over adjacent. So because of that, I am going to draw a right triangle. I am going to put theta somewhere. I always write it in the bottom right corner. That's just where I always write theta. You can write it up top. It doesn't make a difference. And we said tangent is opposite over adjacent, which means the opposite side needs to be the variable u and the adjacent side is the variable 1, or the number 1. Good? Okay. Now, let's go back to the original problem here. Because the original problem wants us to find the cosine of tan inverse of u. But we just said that the tan inverse of u, right here on this line, was basically theta, which means it wants me to find the cosine of theta, doesn't it? Well, I have theta. Cosine is also from a right triangle. I have theta. And to find cosine, I need adjacent over hypotenuse, don't I? Well, I have the adjacent, but I don't have the hypotenuse. So I need my hypotenuse. How do you find it? Good. To find the hypotenuse, you're going to do u squared plus 1 squared equals the hypotenuse squared. If you don't mind, I'll call it r. Not much I can do there, right? So how do I solve for the hypotenuse? How do I solve for r? You got to take the square root of both sides. Remember, this gives me two answers, a positive and a negative. But since it's the hypotenuse, do you want a positive and a negative answer? Excellent, you don't. You just want the positive answer. Which means the square root of u squared plus 1 is equal to the hypotenuse. So my hypotenuse is a funky looking little root. And if that's the way it is, that's the way it is. You with me? So the cosine of theta is adjacent, which is 1. That's the adjacent side to the theta, over the hypotenuse, which is this lovely square root. Are you allowed to leave the square root in the denominator? Nope, got to rationalize it. Okay, so I'm assuming by now you know how to rationalize. I'm going to multiply numerator and denominator by that square root, and so this is the answer I get. I wrote this trig expression as an algebraic expression in the variable u. And the way I did it was I first started with the order of operations, and I looked inside the parenthesis, and the parenthesis told me that this inverse function was actually equal to an angle. And so I substituted and said, hey, well, that means I'm finding the cosine of theta. The tangent gave me two sides of the triangle. I just had to find the third side by using Pythagorean's theorem. And then I could remember that cosine is found by taking the adjacent over the hypotenuse. And once I had the adjacent and the hypotenuse in place, all I had to do was write it down, and in this case, rationalize. Good? Okay. I've got some examples coming your way. Make sure you work on them, though, before you find my answer key video. Catch you on the flip side.